Ladies and gentlemen, today I'm going to present you the vibrometer CM-21M as an instrument for data collection. So in the previous video we have seen how this small vibrometer can operate as a vibrometer. It can measure vibration, it can measure temperature, it can measure rotation speed, do alarming, etc. etc. But of course this collector can work with the routes. And in this way it will collect data according to the route that you have made in the software and then downloaded this route to the data collector. Once we did it, we go to the menu and there is a command like choose route. We enter it and we have a lot of different routes here. So for example, a route for 10 points, we have a route for 5 points, etc. etc. So to start with the data collection and with the route measurements, we need to go to the software and set up the database. Let's do it. So let's look at the Vibrolevel software for the CM-21 vibration meter and data collector. So when you open this software, it will allow you to make stations, to make machines, measurement points, set up some measurements, put alarms, make routes, do condition monitoring, trending, alarming, etc. etc. So first, to set up your equipment, we need to create some station. To do this, we use an open station command and select their empty station. Okay. The empty station will allow us to create a new station. So first we need to give it a name. Let's give it a name like demo station. Okay. In a station we can create a machine. So we add new and create a machine. I have a demo stand, so it will be demo motor. Okay. In the demo motor machine, I will create a point. I have 2 points and I have a special bearing, and I will say that this is bearing 1. And I can make measurements in 3 directions. 1 or just 2 or 3. So we start with vertical and say OK. This will be my bearing 1 in vertical direction. Then I can copy it and paste here and say that this will be in horizontal direction. Okay. And in this machine I will also have the same bearing in axial direction. Let's make measurements in 3 directions. To make any kind of measurements, we need to make a measurement setup. So this is configuration of our equipment, and here we have configuration of measurement setups and of routes. So if we go to configuration of measurement setups, we right mouse click here and say new. We have a new setup. We can select some frequency band. You see that we can have some low frequency measurements with this kind of parameters, high frequency measurements. Then we have some special measurements, etc. etc. For example, I want to make a standard measurements. I have 3000 RPM machine, so ISO will require me this kind of low frequency measurement from 10 Hz to 1 kHz. I would like to have it measured in velocity, but together with velocity I will get all the readings in acceleration, velocity and displacement. And I can select according to the standard RMS, or I can select peak or peak detector. I will select, for example, for acceleration RMS, here for velocity peak, and for displacement peak. This is according to American tradition. I can also write that it will be ISO 10816 part 3. Measurement. Okay. I will save the changes. So I have frequency bands like this. Plus I can do the alarms. So for example, I would like to put an alarm on the velocity, and I will say that in my velocity the low signal will be, for example, 1 millimeter per second. It will mean that machine is not operating. Then for alert I will put something like 5.5 millimeters per second, and for danger I will put, for example, 12 millimeters per second, and I will save changes. So I have my first alarm on these measurements. If I will measure it, I will also get the measurement results, but now it is not here, I have not measured anything. So this is one of the first setups that I have. Another setup I can do, for example, the new, and I can select, for example, low frequency and high frequency. So for low frequency band I will select, for example, the same band, and for high frequency band I can select, for example, from 10 kHz up to 25 kHz. So I will measure velocity in RMS, for example, displacement low frequency in peak-peak, and acceleration high frequency in RMS. For example, like this. I will just also save changes, say this, plus high frequency. Save changes. I can also put alarms. For example, here I can put alarms on velocity and select the alarms again, like 1, 4, 11. Here I measure in RMS. Save changes. I can also put, of course, alarms on high frequency acceleration. Also I can put alarms on temperature. For example, if I have -20 centigrade, and alert will be if I have 50 centigrade, and danger if it will be 80 centigrade, something like this, and we'll save changes. Okay. So these are my temperatures, because the instrument measures temperature together with the vibration. So we have set up two measurements. For example, in vertical I can measure both low frequency and high frequency, and to connect this point and this measurement setup I right click here and say set. So this setup will be in vertical. I do not need to measure high frequency vibration in many directions, it will be more or less the same. But the low frequency is very good to measure in 3 directions. So for example, here I will connect just a low frequency measurement and set. And here for an axial I will also select only low frequency measurement and say set. So now we have different measurements in different points. So this is for demo motor, and this is bearing of it. Also I have a motor, so I can, for example, copy this point and paste it in the demo stand and say that this will be motor. And I will make measurement of it in vertical direction. Okay. I copy it and say that I will, and paste it here, and say that I will also make measurements in horizontal direction. Okay. So now I have set up of my demo stand with bearing, vertical, horizontal and axial, and motor I will just measure, for example, in vertical and horizontal direction. So this is my demo motor. Now I can copy the whole motor and say copy and paste it in the station and say that this will be, for example, real motor. Okay. So I have demo motor with 5 measurements and real motor with 5 measurements. In the same way I can configure all the measurements that I need for all my station. So now I need to create a root and download these two to the root. I go to the roots folder, right mouse click and say new. And say that this is root for demo station. Okay, so I select this route, select this measurement point, and tell it to route. So now it is inside my route. Actually, I can also take the whole machine and say to route, and I can take the whole this machine and say to route. Now we have selected all these measurements in one route, and we can download it to the data collector. So to download it to the data collector, we need to connect our data collector or vibrometer with USB port. It is connected right now, and say load to data collector. So now the process starts and the route is being loaded. Route uploaded to the data collector successfully. So now we go with data collector to make the measurements. So once we created the route and downloaded it to the data collector, we need to select it. We go to the menu, use the choose route command, choose route, and select our route. We have created a route that was called demo station. So this is demo station with 10 measurement points, and we select enter, and this is our route. So we have demo machine and bearing vertical. So what we do? First we connect our accelerometer to the input, align red dots, connected. Then we put an accelerometer to the bearing 1 in vertical position. So here it is. So we connect here, we start our machine, and we press record button here. So now it starts collecting the data. This is the readings, and we save the readings. Yes. Now it says, okay, bearing 1 horizontal. So we take our accelerometer, put it to the horizontal position, like this, and press again the record button here. Here we have some alarm, but this is because we just clicked it. So this is our measurement. It is very stable, like this. And we press enter to save it. Yes. And now it says, okay, put it to Excel. So we take our accelerometer and put it to Excel position, like here. And we press record. Here we have a stable alarm, and this is peak value, 23 millimeters per second, and you see that it continues. So this is very stable alarm condition. And we say save. Yes, we save it. Now it says motor vertical. So we put our accelerometer to the motor vertical position, like here, and we press measure. Now we also measure velocity peak, and you see that it's much smaller. There is no alarm. We look at rather stable, and we say save. Yes. And now it says motor horizontal. Okay, we take our accelerometer, we put it into horizontal direction, and we press measure. We have quite a value. We can look at it. We can save it. Yes. And that's it. You remember that we have created a different machine. We called it real machine. But we may not measure it, because I don't have a real machine here on my table. So we have finished doing this measurement. We can go back to the menu and, for example, review the results. Here is a command, view results. We can enter it, and we see that we have demo motor, motor horizontal. This is the numbers for vibration. This is the motor vertical. This is bearing 1 axial, and you see that in velocity we have quite a big velocity, 16 millimeters per second, and we have 2 millimeters per second in horizontal, and we have velocity 2 millimeters in vertical. So this is the measurements that we can do according to the route. Let's go back to the software and download this route. So we are back with our data collector that we have finished downloading data, and we can connect it to the computer. To do this, we use an USB cable and connect it to the computer like this, vice versa, like this. Then we connect it to the computer jack here, and we have connected the computer. So we go to the software for data download. We select our routes and say unload. So let's go to the screen to see what is going on in the computer. In the computer, in the Vibrolevel software, what we see the routes that are currently in the vibration meter, in our data collector. So we select our route that we have just measured. It is demo station and demo stand. And we say OK. So the data are being downloaded, and it says that we have 10 measurement points and 5 of them are measured. Yes, we have measured just one machine out of 2. Okay. So basically what we have now, we have these points in the demo machine that we have measured. And if we go to the measurement setups, we can see also the measurement results. So here we have the points for acceleration from 10 to 1 kilohertz, for velocity, and we have some alarms here for velocity, for displacement, and for temperature. So we have measured this temperature, we have measured this displacement in microns, we have measured this velocity, 23 point something, it is here, it is above all the levels in the axial direction. And we have some acceleration like 33 meters per second, and we can see acceleration. So here you see that we have alarms set only for velocity, and we have quite a big alarm here. We have displacement, we have temperature, and we are mostly interested in the velocity, and we have measured in vertical. So in vertical it is quite good. In horizontal we do not have, this is acceleration. In horizontal it is quite good. In axial it is quite bad. So these are the measurements. We can also look at the motor. In the motor vertical we have acceleration, velocity, displacement, temperature. In horizontal, acceleration, velocity, displacement, temperature. So this is what we have measured. If we measure it several times, we will have, of course, some kind of a trend here. We can delete data, or we can do the report. So, for example, we can select our machine and do the report. From, for example, for 1 month, from October 11 till today. And we will open this report and save it to the folder that we select. Okay. The report will be created in Microsoft Excel. So the Excel will be open. And we have the report here. So here is the measurement report made by vibrometer CM-21 in this station, DEMO-ST. These are the alarms that we set initially, frequency bands, etc. So we have these alerts, this is what was set up, and this is the report on the measurements. So if we make it full screen, we can see that this is date and time of measurement, and among all of these things that we have measured, we have only one alarm. One alarm is at the velocity measurement in axial measurement point, and it is 23.44. We can compare to the alarms. Alarm for danger is 12, and we have double like this. So this is an Excel, you can edit it, you can print it, etc., etc. So thank you for your attention. This was the vibrometer CM-21 that is supplied with the Vibrolevel software that can set up the database, create routes, make measurements, and finally finish with the report that is very evident, and you immediately see where you have the problems. So thank you for your attention.